Hello everyone and hi to everywhere you are, and I'm happy to sharing you this video of compression test. Here we have the image different, how the process when we are designing it and how we look the result. And here we have a loading plate, you have a mid steel cylinder, and you have a bottom plate in order to fix that mid steel in order to get the result. Yeah, thank you very much, and I appreciate everyone who done to subscribe to this channel. If you are not subscribed, please click down to subscribe and like. Even when you have any comment, any ideas you have to introduce, you can tell me on the comment. I will be here for you to repair you. Okay, thank you very much, and following the step by step in order to finish of this video. At the end of this video, you will get the result you think, and the question you have, it will be solved. Yeah, let's go. We're having a load plate. Let me show you the dimension of the long loading plate. And already done created. You have to click here and edit. You have to see how you see dimension. Yeah, I have a plate. Yeah, I have a 5 millimeters in the dimension. After that, click yes, and the depths, we have two depths millimeters. Yes, the thickness, and you have to see this mid steel. You have to know diameter and radius. You have a radius of 3 millimeters in diameter is 6 millimeter. Yes, the depth we have 12 millimeter. Yeah, thank you. Let's go to the property, and then you see how to assign the property. The property is very important. You have to assign the young modulus, you have to assign the plasticity. Yeah, plasticity, you have 3005, and this is equal to 0. Yeah, I have to see. Yeah, let's go. And then you have to see when your assembly, you have the different top loading plates and bottom loading plate and the cylinder, and then you have to continue to the step by step, and then how to increment, how the in order to taking the time for getting the result. And then to get this one, you haven't getting this one without of interaction between of loading plate, cylinder, and bottom. The bottom have to fix it, and on the top have to loading the loads, and then you have to assign coefficient, you have to assign tangential behavior and normal behavior. Normal behavior have a hard surface, then have to go to the loads, and the load have to see when we are already done create the reference point on there. The bottom have a reference point in order to fix, and the boundary condition fixed. Yes, and then you have to create of the loading point. You have to see this one, and then you have a 4 kilonewton millimeters. As you see when you're following this one, I can, yeah. And then you have to the mesh, have meshing the parts. Meshing is equal to part by part, and then you have to see the loading plate meshed. Meshed is equal to, you have to go, let's go to see how it is meshed. And then the mesh is in the dimension we have already done created in the millimeters. You have to assign this one cylindrical dimension. We have a 0.5 millimeters. Yes, and loading plates, we have 1 millimeters. Yeah, thank you. And then after that, click OK, and then continue to already done. Go to assembly. Yeah, you see how you look it, and then you continue to do the jobs. You have to create a job. Before to create the job, you have to assign where the result will be located after simulating, and then we'll go to saving that the result. The file will be located, and then create, and then create the result. Yeah, click OK, then create your, yes, okay, click, you already done there, okay, yes, click OK, and then save it as already my work is saved. And then go to create a job. Have to create a job, yes, to assign, yes, continue, have to check it, and go to check it. You have to create to the data check. After that, you turn to the data check, yes, submit my work on to the data check. When you have any problem, and when you are signing and have a problem, they are out there monitoring. You have to check what is about Abaqus. Tell me how to change. What is the problem? Yeah, already there is the complete. Yeah, have to learn. When they are not problem, have to continue learning. Just click continue. But my computer is not supercomputer. When you have a supercomputer, the learning is very fast. But if it's not so, it's not supercomputer, you have to waiting time for getting the result. And here we have to see when they are getting the problem. Have to go there to the interaction to change something are there for interaction, and then you see the work is complete. No problem. I have to submit my work. When you are done to submit, I have a waiting for getting the result. The result taking time, and but you have to, if you miss anyone you need, you have test in a comment, and then you tell me what you want to. If you want to work step by step, I here to help you. But if you not, you have to following it. Just when you see this one, here I continue to show you the increment. When my work, you see my computer, not supercomputer already tell you, and then you have to waiting step by step in order to getting the result. Yeah, this is good, and this is a clear when you're done to simulate. Yeah, don't forget to subscribe, and like, comment. Yeah, when you like this one, and we will continue to sharing you different analysis. And if you tell me what you need, and I like to appreciate who tell to search this one. Yeah, here you have to see how the dimension of cylindrical change. Yeah, let's see the graph. The graph here, you see the compression test versus displacement, and then you have to see the maximum force and displacement. Remember that I tell you the unit is it millimeter, and then you have to reach how the big load failure point on the maximum in order to getting the fail. Okay, thank you very much. I hope you done to see the video at the end, at the beginning, up to the end. But remember to subscribe. Click to subscribe and like. Yeah, let's meet again time. Thank you.